Hi dear students, welcome back for the session 2, chapter number 3, data representation. So in the previous session, we discussed about the concept, that is how the numbering systems are classified into two types, as well as the numbering systems, positional numbering system, what are all its classifications. So in the classifications of the numbering system, in the previous session we discussed the two major classifications, that are one is decimal numbering system and second one is binary numbering system. With the help of its radix numbering system, we have a chance to calculate, that is what we called as base and radix numbering system, that is decimal is radix is 10, like that the binary is radix is, that is 2. So that is what we called as types of the numbering system, that is in the positional numbering system, the two category. In that continuing, if I coming to the third type of the numbering system, that is what we called as octal numbering system, dear students. So in the octal numbering system, as the name it is telling, octal numbering system, the base of the radix are, that is 8. Then what are all the numbers you will get in this particular type of the numbering system, that are 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 are the octal numbering system. So dear students, from this topic now we are concluding, with the help of any type of the numbers, like if it is a binary or a decimal, yes, we have a chance to convert that number into its octal form, as well as if any octal number is there, yes, we have a chance to convert into its decimal number. Now I will show you one best example. With the help of that example, you will coming to know whether a conversion of the numbering system with the help of the how the numbers are converted with the octal numbering system, that is 0 to 7. So with this example, now I am explaining how the total numbers of the systems are classified into major octal numbering systems conversions. Okay, so this is a one types of the numbering system. This is what we called as the base 8 octal numbering system. So the number is 61273.15. That is a one type of the octal number. Now how we are having a chance to convert this octal number into its decimal number? See, let us see the total number, dear students. So anyhow, 61273, calculate 0, 1, 2, 3, 4. Hence now I am considering the maximum weightage of the digit is 4. But this is in a type of the octal number, hence that is a radix number. So in the weights of the column, weight of the row, now I am considering 8 to the power of 4, 8 to the power of 3, 8 to the power of 2, 1, 0, minus 1, minus 2. See here, this is what we called as 0, 1, 2, 3, 4. Okay, 4, 3, 2, 1, 0, minus 1, minus 2. So this is what calculations. Then what the numbers we are given in the digits, 6, 1, 2, 7, 3, 1, 5. Fill that in the digit form. Now you calculate. 8 to the power of 4 means, 8 to the power of 4 means, you know, 8 into 8 into 8 into 8, like that 4 times. So 8 to the power of 4 value is 4096. Like that 8 to the power of 3 is 512. Like that 8 to the power of 2 means 8 into 8, that is 64. 8 to the power of 1 means 8. 8 to the power of 0 means 1. So anything to the power x to the power of n, anything to the power of 0, that is equals to 1. That's why x to the power of 0 is 1. Like that 8 to the power of minus 1. X to the power of minus n is equals to 1 divided by of x to the power of n. Like that 8 to the power of minus 1 is equals to, so 1 divided by 8 to the power of 1. So 1 divided by 8 to the power of 1 means the value is 0.125. Like that 8 to the power of minus 2. 8 to the power of minus 2 is 1 divided by 8 to the power of 2. So 1 divided by 8 to the power of 2 means 1 divided by 8 into 8, 64. 1 divided by 64 means the value is 0.0562. So this is what we call as calculation. So 1 divided by 8 to the power of 2 means 1 divided by 64. 1 divided by 64 means that is 0.0562. So now you having a chance to calculate. This is what we called as 4096 into 6. Then you will get one value, that is 24,576. Like that, 500 into 12 into 1, 512, plus 64 into 2, 128, then 8 into 7, 56, then 3 into 1, 3, like that, 1 into 1.25, 0.125, and 5 into 0.0562, that is 0.78125. Then if you add all these decimal values, you will get a decimal digit, that is 25,275. 25,275 point, that is 203125. 203125. So this is what we called as a decimal number of by adding all these digits. See here, up to 3 you will get by adding all these 25,275, and by adding 0.125 plus 0.78125 you will get 0.203125. Then I will write that is as a one decimal number. So by like this we have a chance to calculate or convert any type of the binary or octal numbers. Yes, we have a chance to convert that into its decimal numbering system with the help of this format: weight, digits and value. You can take any other numbers. You can take any other numbers for the simple calculation for like that octal numbers. But whenever you are taking the questions, all the numbers it should be 0 to 7. Remember. So that is what we called as octal base. Consider that any types of the number, make the own octal numbers and convert the octal numbers into decimal number. Now you will get one idea what will be the octal number and its conversion. Then after the octal number system, we will coming to know one more last positional numbering system, that is hexadecimal numbering system. After octal numbering system, dear students, in positional numbering system, the last positional numbering system, that is hexadecimal numbering system. So what is the difference between decimal and hexadecimal? So very similarities. So decimal, the base radix 10, hexadecimal, the radix is 16, hexa. So 16, 6 digits more, hexadecimal. So 16, which number has its radix 16, 16. That 16, that type of the numbering system is what we called as hexadecimal numbering system. See, dear students, before going to the conversions of the hexadecimal to decimal, now I want to give one suggestion. Don't confuse about decimal and hexadecimal, because we saw whenever we are doing regular classes and when we are seeing the answer sheets, so many students, they are confusing for decimal and hexadecimal numbering systems. They will write base 10, but they will convert that number with hexadecimal digits by giving the some characters. Or they are given some characters but showing, they are telling that is a decimal number, like that. So similarity is there, but not a same property here. That's why hexadecimal, the radix is 16. Decimal, the radix is 10. Now we are going to read about hexadecimal numbering system. Hence the radix is 16, 16. So then what are all the numbers we will there in the hexadecimal numbering system, like decimal 0 to 9, binary 0 and 1, octal 0 to 7, like that, what are all the numbers you will get in the hexadecimal numbering system? So dear students, now I will show you the maximum numbers what we are using in the hexadecimal numbering system. Okay, see, clearly observe. From 0 to 15, correct? Hexadecimal means 0 to 15. Total numbers of the weights are 16. But how I will write? This is very important here. Just observe this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12, 13, 14, 15, correct? Yes, of course that is correct. But after 9, up to now this is in a decimal, isn't it or not? Up to 0 to 9, this is a decimal. But now I want that is a hexadecimal. Another 6 digits I want. But that another 6 digits, if I continue with the numbers, the next digit is 10, correct? The next digit is 10, but I will not write number 10. Instead of 10, I will write that is A. Instead of 11, I will write that is B. Instead of 12, I will write C. Instead of 13, I will write D. Instead of 14, that is E. And instead of 15, that is F. Now, in your mind, one question will arise. Why instead of 10, A will come? Why instead of 15, F will come? Very simple. Here there is no that much complicated topic. Very simple. If I write 10 here, if I write 10 here, the 10 is in a combination of the 2 digit, that is 1 and 0. Correct? But here all the digit now I want to write with the help of the single digits. Sometimes this 10 will be accepting like 10 as a binary number. Or this is in a combination of 2 digit 1 and 0. Already that 1 and 0 will come, that already it came in between 0 to 9. See, 1 and 0, that is 10. Like that 11, already this 1 and 1 already it is coming in the decimal number, that is like a 1 and 1, 11. Whenever we are writing a single hexadecimal digit, so we will not consider 10, 11, 12, 13, 14, 15 are the numbers. Instead of that numbers, now we given some character representation for 10 to 15, that is 10 is an A, 11, 12, 13, 14 and 15. 15. So this is what we called as numbering representation of a hexadecimal type. So 0 to 15 are the numbering systems. With the help of the 0 to 15, then its radix is 16, 0 to 15. So 16 digits are there. So this is what we called as hexadecimal numbering system. Remember, dear students, instead of 10, I wrote A. Instead of 11, I wrote B. Like that 12, C. 13 D, like that 14 E and 15 F. So this is the code I used in the hexadecimal numbering system. So this is what we called as hexadecimal numbering system. Now I will consider one best example, and after that we have a chance for the conversion. Consider one best example. So after the hexadecimal representation 10 to 15, that is A, B, C, D, E, F. Now I will consider one best example for the conversion. The example is 5AF point D. This is one example. Now I want to convert this hexadecimal number into its decimal number. Okay, just follow this same step. Weights, digit and value. Okay, then consider from the decimal number, decimal fraction 0, 1, 2. Okay, 0, 1, 2. Hence 16 to the power of 2 I will consider the maximum digit. Why 16 to the power of 2? You know, must and should know the radix is 16, hence 16 to the power of 2. Then, so 16 to the power of 1, 16 to the power of 0. Yes. Then after decimal, you have one more digit, that is 16 to the power of minus 1. Then apply the digits. What do you have? 5 A F point D. 5 A F point D means, so 5 anyhow you know, 16 to the power of 2 means 16 into 16. Okay, see dear student, by this example, so weights are 16 to the power of 2 to 16 to the power of minus 1. Wow, 0, 1 to 16 to the power of 2, 0, okay, 1, 2 and 16 to the power of minus 1. These are all the weights what we are given. Like that the digits 5AF, 5A and F. Okay, you anyhow you know the decimal value 5, it doesn't changes. But instead of A, now I will consider, that is A is equals to 10 here. Of course here representation is A, but the value is 10. Instead of A, instead of 10 I wrote that is a A. That's why the value of A is here 10. Like that the value of F is 15. Okay, then the value of D is like that, that is 13. So now you calculate, see here, 256 into 5, 1280. 16 into 10, 160. 15 into 1, 15. Like that, 13, this one. See here, for your calculation I will write here. 16 to the power of minus 1, okay, that is equals to 1 divided by 16 to the power of 1. 1 divided by 16 to the power of 1 means that is 0.0625. 0.0625 into 13. So into 13, then the value is 0.8125. So 0.8125. Now you add all these elements. Now you add all these elements, 1280 plus 160 plus 15 plus after decimal 0.1285. Then the answer is 1455.8125. This is the decimal value of that particular hexadecimal number, dear students. Like this, we have a chance to convert any type of the hexadecimal number into its decimal number. This is a very small example we shown in the demonstration, how we have a chance to convert that into its decimal numbers. Like that you have a chance. Dear students, now you consider any other numbering system. Just I will give some assignment. BAC point F. Consider this one hexadecimal number. Convert it into decimal number. This is the assignment I am given. So like that, FAC point A, like that 16. Convert that into decimal number. Okay, so you consider these two hexadecimal number and convert that into its decimal number by like this. Then you will coming to know how to convert any type of the numbering system, that is hexadecimal to decimal. We are following this as a method to conversion of any type of the numbers. So dear students, in this particular session you learn about conversions of the numbering system, that is in the positional numbering system, especially the two types. One is octal number system 0 to 7 octal number system, the radix is 8, as well as hexadecimal numbering system 0 to 15, but after 9 instead of 10 I wrote A, like that instead of 15 I wrote F. So 0 to 15, the maximum weightage of the digits are 15, and 0 to 16, so the radix is 16. Like that you have a chance to convert all the hexadecimal numbers into its decimal number. We practice on these assignments and you are coming to know how to convert the hexadecimal into decimal, dear students. After this we are going to some vice versa conversions after the hexadecimal number, decimal to binary, binary to hexadecimal, like some inter conversions will come after this session. We are going to learn about that concept in the next session, session number 3, dear students. Until then you practice these all the 4 types of the number conversions. Thank you.